Okay, today I'm starting a new project. Been commissioned to do a custom project, which I do every now and then, and I've done for this person before. Basically this time he's got this idea of a telephone type robot. The old phones that had the crank, the newer phones that had the dial. You've got a claw, kind of a telephone type body, kind of a bell type head, and the old telephone type headset. And he'd already hired someone to do this 3D render of what he has in mind, or what they proposed and he liked, I don't know. But my job was to recreate this into a mechanical toy. Originally he was just asking for wheels on the bottom so it can move, and that, of course, that isn't going to work. And if you look at how narrow the feet are versus how wide the body is, and you figure there's going to be batteries in there, you know, that's not going to be very stable. So I wanted to make as few changes as possible to the design, but one change I'm going to make is the feet are going to be a little bit wider, and that would be about it. So, and instead of moving on wheels, I'm going to go with a pin walking design, which, if you're not familiar with that, you will be by the time we're done talking about it. He wants the dial to move, and if possible with a digital dialing sound, mechanical sound, and wants the crank to spin, and we'll add a digital bell type sound when the crank is spinning. Originally he was asking for the claw to move, and the only way I'm going to be able to make that claw move, since the claw's attached to the arm, is to make the arm move. So I'll make the arm sway back and forth. Lights in the eyes. And that's pretty much it. So my first job was to figure out the scale. How much room am I going to need to do that? So working from this render, I actually did a print. Let me dig that out. Got it over here, I think. Maybe. Yeah. Here it is. And it was just printed out of scrap PLA, so it was different colors. But by doing this half-face print, I was then able to measure out the area that I think the servos are going to require, and the motor for the walking is going to require, the area for the speaker, the area for the Pololu Mini Maestro controller. It's a 6-channel controller. And the main thing was, will the body be big enough to hold 4 AA batteries, which is what's going to be needed to run the servos and the microcontrollers and all of that. So when I started scaling everything up, and I'm looking, trying to figure out the best way to find all of the other images I have here. Let's make that small and see if they come up with choices here. It's just showing that one. I've loaded them all. And here I thought I was ready. Usually when I hover over my icon, it brings up all of the choices. But not today. Unsaved pages, do you want to ignore? Let's just see what it shows as being other things I open, and maybe we can go from there. Well, let's open this. So here we have the body back. Like I say, the opening needed to be large enough that I knew I could fit in 4 AA batteries, and the battery ends were going to go down below the waist, and that was going to be a problem if I was going to use an off-the-shelf battery holder like this, because they always alternate, one in the negative, then positive, then negative and positive. And the problem with that is the ones that have the positive end that would go down, you would have a spring here, and there's no way to compress it. If you start the negative end like you're supposed to and compress the spring, you can't slide the positive in because it goes down too low. So I needed to design a battery holder just for this project. And before we close this out, we'll talk about here on the bottom. I put a place for the on-off switch, place for mounting screws to hold it together. There's going to be an area here. Well, actually the motor doesn't mount to this half, but there has to be room for the motor there. Here's an area for the speaker and a place for the sound to come out from the speaker underneath the back of the head. So let's close that out. I don't know why it didn't keep all the other ones open. Always has in the past. So let's see, if I just hit open, does it show some of the others? Yes, it shows some of the others. Let's, but it doesn't really tell me what they are. That's back. We've already looked at the back. That's back, 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 back. It's phone parts. I was looking for the battery box if it was on there. I don't see it. Body front. Well, let's take the body front image from here. So here's the front of the body, and this is where the dial indexer arm will be. Most of the fun of this one happens, of course, on the inside. You've got the slot for the pin walking mechanics to go down. This is where the motor I'm going to use to drive the pin walker will mount. And this is the mount for the dial servo, which will be a continuous rotation servo, which means I can stop it or turn it in any direction. And there'll be a continuous rotation servo over here on the crank arm side, but on the arm that just moves back and forth, there'll be a normal 90-degree servo that'll nest in there. And I'll be putting 2 millimeter threaded rod into the end of the servo and come out, and then that'll connect to the arms. Then the eye holes I've set for a 10 millimeter LED opening, and the rest of the space is gutted out in the hopes that I can fit the Pololu Mini Maestro 6-channel controller up in here. Actually, there won't be any problem putting the controller in there. What I'm not really sure about yet is once you put all of those servo plugs, they're fairly long, whether it will be deep enough for all of that to fit in there. I'm hoping that will. These notches are for the phone stuff you saw earlier in the drawing that went up to the phone that sits up on top. And these basically will be the parts that I'll attempt to print out. So let's try a new scene. Let's see what comes up now. I think the only way we're going to find this stuff that I wanted to show you is to simply go back in to the original file. And here's the battery box I was going to show you. Let's take a look at that. So there's the battery box, all designed. So all the negatives and the spring ends will be down here. So I can push the battery down inside and pop the positives in, and so they'll all be in the same angle, and that'll fit into the body. So what else have we got? There will be a door on the back of it once it's done, and this will be the door that will go over where the batteries are. Or at least I'm hoping that will be the door. We'll find out. Where is the dial? Here's the dial. This dial fits on the end of the servo that sticks through the front of the body. Now, of course, on a real phone dial, there are 10 circles, but there's a space for 11 circles. But the 11th circle is left out. That's because that indexing arm is right like here. So if you're going to dial 1, there had to be room to move it down so it could go back up. Then 2 down and back up. But in this case, since I'm using a full rotation servo that I can move in both directions, you know, so I can move it any way I want. For the illusion to work better, I just went ahead and evened out the circles to go all the way around. And let's see, what else have we got here? the leg cam. That's the cam that's going to go on the motor. There'll be two of them, one on each side for driving the leg linkage. In fact, let's just check the leg linkage out here. There's one of the links. The cam goes in this part here, so it'll move that. This becomes a pivot within the little trough slits that you saw on the body, front and rear. That forms the pivot point that determines how much this moves forward and backward. The offset of that cam determines how much the pin moves up and down. So you got your up and down control, and you got your forward and backward control. See if we have anything else here that would be of interest. A lot of the details up on the top I'm working on. They're not really done. Well, the feet. To keep the thing stable, I'm going to go with an articulated foot, which means I have to go in with a screw in the front and the rear so that this foot can tip on the body. That way when the body on a pin walker, they lift and then move and then drop. And if you leave it rigid, they become very unstable, and they usually tend to fall backwards. If you happen to have a vintage pin walker, you know what I mean, they fall over a lot. But if you articulate the feet, then they'll suddenly become very stable, and they do not fall over. What else have we got here? Arm crank. The arm crank's actually going to be in more pieces. This knob part will be separate from the arm crank. I'll put a threaded rod in there, a track, and a nut on the inside so that this handle can actually spin. And there will be that threaded rod that comes off the servos, the 2mm threaded rod will come through. There'll be a locking nut, a washer, and then a rubber O-ring that all fit up inside there. And then the rod will go into the smaller hole. And then on this side over here, there'll just be a flat washer and a couple of locking nuts to lock it on. And by doing that, I should be able to adjust the pinch tight enough where this will move around and respond to the servo, but still slip enough if someone grabs this and tries to manually move it, they don't break the servo. So it'll act like a slip clutch, I'm hoping. Anyway, that's the plan. Arm claw, the other side. Here we go. So this will print as you're seeing it, and again the same type of mechanism will be going on here. I'll go in with a locking nut on the shaft, flat washer, rubber grommet in there, and then over on this side, flat washer and locking nut, and adjust the tension again so the servo can make the arm move back and forth as it's walking, and yet if someone grabs it, it can slip and they won't end up breaking anything. Or at least that is the plan. The plan could change at any time, and probably will. So I think those are the main parts on this project. I have done work with this guy before, and it was 2-3 years ago. He wanted to take this Buck Rodgers type rocket and robot from the comics, but turn it into an actual toy. And I actually turned it into a couple of different versions. I did my own version and then did a version that is very closely based on the comic book. And I'll put a link to this project and video down below if you want to see how that turned out, because it's actually wax, and as you can see, it's quite small. So stay tuned for the next parts, which I guess would be printing out some of the parts and seeing if they fit.